Welcome, fellow stargazers, to our grand tour of the cosmos. Tonight we embark on a journey through the celestial tapestry, exploring the wonders of the Messier Objects. This collection of over 100 celestial objects, from shimmering star clusters to distant galaxies, offers a glimpse into the vastness and beauty of our universe. But before we set our sights on these cosmic wonders, let's take a moment to appreciate the man who made it all possible. Charles Messier, an 18th century French astronomer with an insatiable curiosity for the heavens. Born in a time when the night sky was still a mysterious and uncharted realm, Messier's passion for astronomy ignited at a young age, sparked by the fiery spectacle of a comet blazing across the sky. Imagine young Charles, gazing up at the night sky, captivated by the celestial dance of stars and planets. He yearned to unravel the secrets hidden within those twinkling points of light. As he grew older, his fascination with the cosmos only deepened. He became particularly interested in comets, those icy wanderers that graced our skies with their ethereal presence. Armed with a telescope, a precious and rare instrument in his time, Messier dedicated himself to scouring the heavens, meticulously charting the positions of stars and diligently hunting for new comets. His relentless pursuit led him to discover numerous comets, earning him recognition and acclaim throughout Europe. But amidst his cometary conquests, Messier encountered a recurring frustration. Our cosmic voyage begins with Messier Object M89, or M89 for short. Located about 50 million light-years away in the constellation Virgo, M89 is an elliptical galaxy, a cosmic island of stars with a distinctly smooth and featureless appearance. Unlike their spiral counterparts, elliptical galaxies lack the swirling arms and vibrant star-forming regions that make galaxies like our own Milky Way so visually captivating. Instead, M89 presents itself as a giant cosmic football, a vast swarm of stars held together by gravity's invisible hand. These stars, many of them ancient and nearing the end of their stellar lives, orbit the galactic center in a chaotic yet strangely harmonious ballet. Through our telescopes, M89 appears as a faint, diffuse glow, a testament to the immense distances that separate us from these celestial wonders. But don't let its seemingly simple appearance fool you. M89 harbors secrets that continue to intrigue astronomers to this day. For example, observations suggest that this galaxy may be home to a supermassive black hole at its core, a gravitational behemoth millions or even billions of times the mass of our Sun. These cosmic monsters lurk in the hearts of most, if not all, massive galaxies, shaping the evolution of their host galaxies with their immense gravitational pull. M90, a breathtaking spiral galaxy located approximately 60 million light-years away in the constellation Virgo, stands in stark contrast to the smooth, featureless appearance of its elliptical neighbor, M89. This majestic spiral, with its graceful arms swirling outward from a central bulge, presents a captivating spectacle of cosmic beauty and dynamism. Its spiral arms, adorned with luminous blue stars and intricate dust lanes, trace the intricate dance of gravity and star formation. These arms, far from being static features, are constantly in motion, rotating around the galactic center like a celestial pinwheel. As we observe M90 from our vantage point millions of light-years away, we are witnessing the culmination of billions of years of cosmic evolution. Each star, each dust cloud, and each spiral arm tells a story of stellar birth, life, and death. We've traversed the vast cosmic ocean, encountering elliptical and spiral galaxies, and now we arrive at a celestial object shrouded in a bit of mystery, Messier 91. Catalogued by Charles Messier in 1780, M91 is classified as a barred spiral galaxy, but its story is more tangled than its spiral arms. You see, Messier, observing from his Parisian rooftop, meticulously recorded the position of M91. Yet, for over a century, astronomers searched in vain, unable to locate a galaxy matching his description at the coordinates he'd logged. Had Messier made an error, a miscalculation in the vast cosmic map? The answer, as it often does in science, lay in meticulous re-examination. In 1969, an astronomer, painstakingly reviewing Messier's original notes and comparing them to modern sky surveys, realized the recorded position was slightly off. A simple error, a slip of the pen perhaps, had misplaced M91 for over a century. And what did they find at the corrected coordinates? A stunning barred spiral galaxy, its arms swirling outwards from a central bar of stars, a cosmic dance captured in the fabric of space-time. Our journey now takes us from the swirling majesty of spiral galaxies to a celestial object of a different order, a celestial sphere teeming with stars, ancient beyond imagination, Messier 92, a globular cluster residing in the constellation Hercules. Imagine a sphere, densely packed with hundreds of thousands of stars gravitationally bound, a cosmic swarm of fireflies against the velvet backdrop of space. That's M92, a stellar city, a relic from the early universe. These globular clusters scattered around our Milky Way and other galaxies are like time capsules, preserving the universe's early chapters. The stars within them are some of the oldest known, formed billions of years ago, long before our sun even ignited. Studying M92 is like peering into the universe's childhood, decoding the chemical fingerprints of these ancient stars to understand the conditions present in those early epochs. It's a window into a time when the universe was young and the first galaxies were just beginning to take shape. From the ancient stellar metropolis of M92, we shift our gaze now to a younger, more loosely knit gathering of stars, Messier 93, an open cluster residing within the constellation of Puppies. If globular clusters are like densely populated cities, open clusters like M93 are more akin to small towns, their stellar inhabitants numbering in the hundreds rather than hundreds of thousands. Open clusters are relatively young, astronomically speaking, often forming from the same giant molecular cloud, a stellar nursery where gas and dust coalesce to ignite new stars. These sibling stars, bound by gravity, then drift together through space, a sparkling family portrait against the cosmic canvas. Unlike their tightly packed globular counterparts, open clusters are more loosely bound, their stars more susceptible to being pulled away by the gravitational tides of the Milky Way as they journey through the galaxy. Messier 94, or M94, as we cosmic cronies call it, a spiral galaxy about 16 million light-years away in the constellation Canes Venatici, the hunting dogs. From our vantage point, we see it nearly face-on, its spiral arms unfurling like a celestial pinwheel. But don't let those deceptively tranquil arms fool you. M94 harbors a secret, a mystery that has puzzled astronomers for decades. You see, nestled within those graceful spiral arms lies a ring ablaze with stellar nurseries. This isn't just any ordinary ring of star formation. This is a starburst ring, a region where stars are being born at a furious rate, far exceeding the usual pace of stellar birth in a galaxy. Imagine a cosmic fireworks display frozen in time, a dazzling spectacle of stellar creation. But what ignited this cosmic firestorm? What could possibly drive such intense star formation in such a confined region? The answer, my friends, remains elusive. Some astronomers believe that a close encounter with another galaxy, perhaps its neighbor M95, sent gravitational ripples through M94, compressing gas and dust and triggering the birth of countless stars. Others speculate that the galaxy's own spiral arms, through their gravitational influence, are shepherding gas and dust into the ring, fueling the inferno of star birth. The debate rages on, a testament to the enduring power of the cosmos to surprise and challenge us. Our journey through the cosmic sea of Messier objects now brings us to M95, another resident of the constellation Canes Venatici. This time we encounter a barred spiral galaxy, a magnificent structure with arms spiraling not from a central sphere, but from the ends of a luminous bar cutting across its heart. This bar, my friends, is more than just a cosmetic feature. It's a gravitational engine, funneling gas and dust towards the galaxy's center, fueling the formation of new stars and shaping the destiny of the galaxy itself. Imagine a cosmic river, its currents guided by the invisible hand of gravity, carrying the raw materials for starbirth to their fiery destination. As we gaze upon M95, some 50,000 light-years across and lying roughly 38 million light-years away, we witness the interplay of forces that have sculpted galaxies throughout the universe. Gravity, the master architect, shaping vast clouds of gas and dust into these grand spirals, these islands of light scattered across the cosmos. But M95 has a secret, a hidden treasure lurking beneath its veil of stars and gas. Deep within its core, obscured from our view by swirling clouds of interstellar dust, lies a supermassive black hole, a gravitational abyss millions of times more massive than our own sun. Our celestial voyage now brings us to M96, another denizen of the constellation Leo the Lion. This time, we encounter a majestic spiral galaxy, a swirling island universe composed of billions upon billions of stars, each a sun in its own right, perhaps harboring planets of their own. M96 is a true heavyweight, a galactic giant spanning over 100,000 light-years, even larger than our own Milky Way. Its spiral arms, painted across the cosmos with delicate brushstrokes of starlight, are a testament to the intricate dance of gravity and matter that shapes these grand structures. As we gaze upon this distant realm, some 35 million light-years away, we are reminded of the vastness of the cosmos and our place within it. We are but a small part of this grand cosmic tapestry, a single species on a single planet orbiting a single star among billions upon billions in a universe teeming with galaxies. And yet, in this vast cosmic ocean, M96 stands out, a beacon of light and complexity, its silent symphony of starbirth and galactic evolution playing out across the eons. From the spiraling grandeur of galaxies, we turn our gaze now to a smaller, yet no less profound wonder of the cosmos. Messier 97, better known as the Owl Nebula, floats silently in the constellation Ursa Major, a celestial bird frozen in mid-flight. Don't let its seemingly diminutive size fool you. This cosmic owl, spanning a region of space 3 light-years across, represents the final spectacular chapter in the life of a star very much like our own sun. What we are witnessing is a cosmic ballet of sorts, a delicate interplay between the star's fading light and the outward push of its outer layers shed over millennia. This expelled material, enriched with the building blocks of life itself, forms the nebula we see, a ghostly visage illuminated by the dying star's embers. Over eons, these stellar ashes will disperse into the interstellar medium, seeding the cosmos with the potential for new stars, new planets, and perhaps even new life. The Owl Nebula, in its quiet demise, reminds us of the cyclical nature of the universe, a cosmic dance of creation and destruction that plays out on a scale beyond human comprehension. Our journey through the Messier catalog now takes us from the quiet grandeur of a dying star to the vibrant dynamism of a galaxy in motion. Messier 98, a stunning spiral galaxy located some 45 million light-years away in the constellation Coma-Berenices, is a testament to the ceaseless dance of the cosmos. Unlike many of its galactic brethren, M98 presents itself to us at a rather dramatic angle. We see it nearly edge-on, its spiral arms and central bulge compressed into a narrow, luminous band across our telescopes. This perspective, while perhaps not showcasing M98's full grandeur, provides us with a unique opportunity. It allows us to study the structure of a spiral galaxy in profile, to observe the distribution of its stars, gas, and dust in a way that a face-on view wouldn't allow. And what a view it is! We see bright knots of star formation, glowing with the intense light of newly born stars, strung along its spiral arms like celestial pearls. We see dark lanes of dust and gas, the raw materials for future generations of stars silhouetted against the galaxy's luminous disk. M98 is a living, breathing entity, a testament to the ceaseless cycle of stellar birth, life, and death. Our cosmic voyage continues, and we find ourselves now face to face with a celestial masterpiece, Messier 99, a grand design spiral galaxy located some 50 million light-years away in the constellation Coma-Berenices. Unlike its neighbor, M98, which we observed edge-on, M99 presents itself to us in all its full frontal glory. And what a sight it is! Its perfectly symmetrical spiral arms, traced by luminous blue stars and dark swirling dust lanes, seem to stretch out towards us like the arms of a cosmic dancer. This type of spiral galaxy, with its well-defined arms and a prominent central bulge, is known as a grand design spiral, and M99 is a textbook example of the type. Its elegant structure is a testament to the intricate interplay of gravity, rotation, and star formation that governs the evolution of galaxies. As we gaze upon M99, we are witnessing the intricate dance of hundreds of billions of stars, each tracing out its own path through the vastness of space, yet collectively contributing to the galaxy's breathtaking beauty. Welcome, fellow travelers, to the grand spiral galaxy Messier 100, or M100 for short. Located about 55 million light-years away in the constellation Coma-Berenices, M100 presents itself face-on to us, offering a breathtaking view of its structure. Imagine, if you will, a swirling disk of stars, gas, and dust, a cosmic carousel spanning over 100,000 light-years across. This is M100, a giant amongst galaxies, even larger than our own Milky Way. As we gaze at this image, we are seeing light that began its journey towards us when dinosaurs still roamed the Earth. Within this light lies encoded the story of M100, a tale of starbirth, galactic evolution, and the intricate dance of gravity. Our next stop takes us to the constellation Ursa Major, home to the magnificent Pinwheel Galaxy, also known as Messier 101. Unlike M100, which presented itself face-on, M101 is tilted at an angle, giving us a mesmerizing perspective of its spiral structure. Imagine a cosmic pinwheel, its delicate arms flung out across the vastness of space. That's M101, a sprawling spiral galaxy over 170,000 light-years across, nearly twice the size of our own Milky Way. The Pinwheel Galaxy is a hotbed of star formation, its arms ablaze with the light of newly born stars. These regions are some of the most luminous in the known universe, shining with the energy of millions of suns. But M101 harbors a secret, a mystery that has puzzled astronomers for decades. Our journey through the Messier catalog takes us now to M102, an object shrouded in mystery and debate. Unlike other entries in Messier's list, the identity of M102 has been the subject of much controversy. Some astronomers believe that M102 is simply a duplicate observation of M101, the Pinwheel Galaxy we just visited. Errors in recording positions were not uncommon in Messier's time, and it's possible that M102 is simply a phantom entry. However, other astronomers argue that M102 is a real object, a separate and distinct galaxy. They point to a faint lenticular galaxy known as NGC 5866, located in the constellation Draco, as a possible candidate. The debate over M102's true nature continues to this day, a reminder that even in the age of modern astronomy, mysteries still abound in the cosmos. We journey now to the constellation Cassiopeia, named for a vain queen in Greek mythology, but far more interesting for the celestial wonders it holds. Here, nestled amidst the cosmic tapestry, lies Messier 103, a relatively young, open cluster of stars. Unlike the ancient and tightly bound globular clusters, open clusters are like stellar nurseries, cradling newborn stars still coalescing from the interstellar medium. M103, though smaller and less densely packed than its globular cousins, presents a dazzling sight in even modest telescopes. Imagine, if you will, a sparkling sprinkle of diamonds scattered across black velvet. Each point of light, a fiery furnace, a star brimming with the potential for planets, perhaps even life. At a distance of roughly 8,000 light-years, the light we see from M103 began its journey towards us when our ancestors were taking their first tentative steps towards agriculture. This cluster, with its youthful energy, reminds us that the cosmos is not a static, unchanging tableau, but a dynamic, ever-evolving spectacle. As we observe these stellar infants, we are witnessing the very processes that birth stars and shape the galaxies, including our own Milky Way. Our cosmic voyage now takes us from the familiar sights of our own galactic neighborhood to the distant realm of galaxies beyond. Prepare yourselves, for we are about to encounter Messier 104, better known as the Sombrero Galaxy, a celestial masterpiece that never fails to evoke a sense of awe and wonder. Located some 31 million light-years away in the constellation Virgo, the Sombrero Galaxy, true to its name, appears as a grand flat disk tilted at an alluring angle, revealing its brilliant core and a prominent dust lane that bisects its structure. Imagine, if you will, a cosmic frisbee, its edges shimmering with the light of billions of suns, its center a mysterious bulge shrouded in a veil of interstellar dust. What makes the Sombrero galaxy particularly fascinating is its orientation. We view it almost edge-on, as if we are peering at a cosmic dinner plate from the side. This unique perspective allows us to study the structure of a spiral galaxy in exquisite detail, revealing the intricate spiral arms, the central bulge teeming with stars, and the dark, dusty lanes where new stars are being born. Our cosmic journey continues, and our next destination brings us to the constellation Leo, the celestial lion. Here we encounter Messier 105, a majestic elliptical galaxy, a colossal island universe vastly different from our own spiral Milky Way. Unlike spiral galaxies with their graceful arms and active star formation, elliptical galaxies like M105 appear smooth and featureless, resembling giant cosmic marbles. They are composed primarily of older reddish stars, giving them a warm golden glow. These galaxies, often found in the hearts of galaxy clusters, are thought to have formed through mergers of smaller galaxies, their individual structures blending together over billions of years. M105, located about 32 million light-years away, is a giant among galaxies, stretching over 100,000 light-years across. To put that into perspective, if we could somehow shrink our Milky Way down to the size of a dinner plate, M105 would dwarf it, appearing as large as a car tire. And now we venture off to M106. A spiral galaxy much like our own Milky Way at first glance. You see the familiar disk, the graceful arms spiraling outwards, a cosmic pinwheel set against a backdrop of distant starlight. But don't be fooled by appearances, for M106 holds secrets that set it apart. Secrets that whisper of powerful forces at play within its starry heart. Located some 22 to 25 million light-years away in the constellation Canes Venatici, M106 spans over 130,000 light-years. That's right, over 100,000 years for light, the fastest thing in the universe to travel from one end of this galaxy to the other. Imagine the sheer scale of it, the countless stars and planets that reside within this magnificent structure. From the majestic spirals of M106, we journey now to a very different kind of stellar congregation, a celestial time capsule that offers us a glimpse into the distant past of our own Milky Way. Messier 107, a globular cluster residing some 20,000 light-years away in the constellation Ophiuchus. Imagine a sphere of stars, a tightly bound collection of hundreds of thousands of ancient suns, all orbiting a common center of gravity. Unlike the scattered stars of open clusters, the stars in globular clusters are packed incredibly close together, especially towards the center, where the density of stars can be 1,000,000 times greater than in our solar neighborhood. M107 is one of over 150 globular clusters that orbit our Milky Way galaxy, like ancient moths circling a cosmic flame. These clusters are thought to be relics from the early universe, formed shortly after the Big Bang, when the universe was a much smaller and denser place. The stars in globular clusters are some of the oldest known, containing very few heavy elements. This tells us that they formed before generations of stars had a chance to seed the universe with heavy elements through supernova explosions. In a way, these clusters are like time capsules, preserving a record of the early universe and providing clues about the conditions under which our galaxy formed. From the ancient realm of globular clusters, we shift our gaze now to a more familiar sight, a spiral galaxy shimmering in the constellation Ursa Major. Messier 108, located some 45 million light-years away, M108 might seem like just another face in the cosmic crowd, but don't be fooled by its apparent ordinariness. At first glance, M108 might appear as a classic spiral galaxy, with its swirling arms and central bulge. But look closer, my friends, and you'll notice a subtle yet significant feature, a bar-shaped structure cutting across its heart. Yes, M108 is what astronomers call a barred spiral galaxy, a type of galaxy that's surprisingly common in the universe. And now we journey to the constellation Ursa Major, home to the Big Dipper and a cosmic masterpiece known as Messier 109. This barred spiral galaxy, much like our own Milky Way, boasts a central bar-shaped structure composed of stars, gas, and dust. Imagine a celestial bridge, a cosmic thoroughfare where stars congregate and stellar nurseries ignite. giving birth to generations of new stars. M109 lies roughly 48 million light-years away, a vast distance that underscores the profound scale of the universe. If we could travel at the speed of light, the ultimate cosmic speed limit, it would still take us 48 million years to reach this majestic island universe. And yet, even across such an unfathomable gulf, we can still marvel at its beauty and decipher its secrets. As we gaze upon this image, we witness the intricate dance of gravity, the force that sculpts galaxies and orchestrates the movements of stars across the cosmos. It's a dance that has been playing for billions of years, and with every passing moment, new chapters in the story of M109 are being written. As we bid farewell to M109, our cosmic journey takes us to M110, a dwarf elliptical galaxy that holds the distinction of being the first Messier object discovered after Charles Messier's initial catalog was published. This faint, yet intriguing galaxy is a satellite of our larger galactic neighbor, the Andromeda Galaxy, locked in a gravitational dance across the vastness of space. M110, despite its diminutive size compared to giants like M31, is a fascinating object in its own right. It contains a surprising amount of interstellar dust, a sign that star formation may still be ongoing within its borders. This challenges our understanding of dwarf galaxies, often thought to be relatively quiescent stellar populations. While M110 may lack the grand spiral arms of its larger companion, it serves as a reminder that even seemingly unremarkable objects in the universe can hold surprises and deepen our understanding of the cosmos. Its proximity to Andromeda also provides astronomers with a unique opportunity to study the interactions between galaxies and the gravitational forces that bind them together. And so, our journey through Charles Messier's catalog comes to an end. But the cosmos, my friends, is boundless. We've explored majestic spiral galaxies, elliptical giants, shimmering star clusters, and the ethereal remnants of stars long gone. We've peered into the hearts of galaxies, witnessing the awesome power of supermassive black holes, and contemplated the vast scales of space and time that define our universe. But this is just the beginning, because out there amidst those twinkling stars lie countless mysteries waiting to be unraveled, stories waiting to be told, and countless wonders waiting to take your breath away. So the next time you find yourself beneath a clear, dark sky, take a moment to remember Charles Messier, that meticulous comet hunter who stumbled upon a cosmic treasure trove. And then, with a heart full of wonder and a mind open to the possibilities, just look up and let the universe amaze you. Stay tuned to the channel where we'll delve even deeper into the cosmos, exploring more celestial wonders that have captivated astronomers and stargazers for centuries. But until then, keep asking questions and never lose your sense of wonder. Because the universe, my friends, is a vast and mysterious place, and there's always something new to discover, just waiting for a curious mind to come along and unravel its secrets. So until next time, stay curious and keep looking up.